Hello, dear viewers, and welcome to an exciting journey into the depths of science and space exploration. Today, we'll explore groundbreaking new findings from NASA, which is searching for signs of life on Jupiter's Europa and Saturn's Enceladus. These distant, icy moons are billions of kilometers away from our planet, but they are attracting the attention of scientists. If you're curious about how exciting the prospect of finding life on these distant worlds is, be sure to watch our video to the end. If you're ready, let's dive into deep space. Europa and Enceladus are icy moons thought to have deep oceans billions of kilometers away from our planet. These moons have a thick layer of ice on their surfaces, but underneath this layer of ice, there could be huge oceans. It is scientifically suggested that there is a giant ocean beneath the icy surface of Europe, and a similar ocean structure under the ice of Enceladus. These oceans may have the potential to harbor life because they may contain the energy sources and organic compounds that life requires. But how can we find traces of life on these distant moons? Recent research by Alexander Pavlov and his team from NASA's Goddard Space Flight Center has revealed very promising findings. Pavlov and his team conducted several experiments to understand how organic molecules can be preserved on the surfaces of Europa and Enceladus. These experiments are critical to assessing the potential of these cold and harsh environments to harbor traces of life. Pavlov and his team discovered that organic molecules can survive about 20 centimeters below Europa's surface, about 8 inches deep. This finding suggests that searching for organic molecules at this depth may be sufficient for exploration missions to Europa. It is stated that these organic molecules can survive, especially in the high latitudes of Europa, where the surface is not damaged much by events such as meteorite impacts. On Enceladus, the situation is a little different. It is stated that amino acids can survive even just a few millimeters below the surface of Enceladus. This means that it may be enough to take samples under a thinner layer on the surface to look for traces of life on Enceladus. Also, the surface of Enceladus is thought to be highly resistant to radiation effects. So, in an exploration mission to the surface of Enceladus, it may be possible to look for organic molecules a few millimeters below the surface. Now, let's dig a little deeper into the harsh conditions on the surfaces of these distant moons. Europa and Enceladus may not be conducive to life due to particles traveling at high speeds and radiation from powerful events in deep space. But beneath their surfaces lie vast oceans heated by the gravitational pull of the planets and neighboring moons. These oceans have the potential to harbor the energy and organic compounds necessary for life. Therefore, the possibility of harboring life beneath these surfaces could be quite high. The research team led by Pavlov conducted extensive experiments to determine how amino acids break down under the influence of radiation. In these experiments, amino acids were tested under very low doses of radiation in environments similar to Europa and Enceladus. They also investigated how long amino acids could survive in the presence of microscopic organisms. Considering that microscopic organisms can preserve amino acids, tests were also conducted in such environments. The results of the experiments are quite interesting. It was observed that amino acids survived longer in the presence of microscopic organisms. This shows that in environments containing microorganisms, amino acids are protected from the harmful effects of radiation and can last longer. It was also found that amino acids degraded faster in areas containing silica. Silica can disrupt the chemical structure of amino acids, making it difficult to find traces of life in these molecules. These findings are very promising for future missions, searching for traces of life on Europa and Enceladus. It is especially important to consider the results of these experiments to assess the potential for finding life on these moons. Scientists need to use this information to plan more effective exploration missions when searching for organic molecules below the surface. It is also emphasized that care should be taken when taking samples in silica-rich regions. So what can we do in light of these discoveries? In future missions to Europa and Enceladus, it is crucial to take the results of these experiments into account when searching for organic molecules below the surface. Keep in mind that amino acids can degrade faster when samples are taken in silica-rich regions. Scientists can obtain more reliable results by taking more careful samples in such regions. Another interesting finding of this research is that bacteria can preserve amino acids. Bacterial cellular materials can protect amino acids from the harmful effects of radiation and help these molecules survive longer. This finding shows what an important role microscopic organisms can play in the search for life. Now we want to ask you a question. Do you think it is possible to find life on Europa and Enceladus? When you think about how amino acids can survive in these harsh conditions, what kind of new discoveries might these findings lead us to make? Don't forget to share your thoughts and predictions with us in the comments. Also, do not forget to subscribe to our channel and turn on the notification bell to follow such exciting developments in the world of science. Every week, we will be here with the latest discoveries and research results from the depths of the universe. Feel free to share your thoughts about scientific news and space exploration with us. See you in the next video. Bye. If you like our video, don't forget to press the like button and share it on your social media accounts. Stay tuned to our channel for more content about scientific discoveries and space exploration. If you have questions or comments, feel free to write below. Science-filled days to all of you.